Okay, so this section is about related rates, and these are going to be basically word problems where we have two things that are related to changing quantities that are related, and we're going to be asked about the rate of change of one of them. So, remember that derivatives can be interpreted as a rate of change, so we're going to be using derivatives to solve these problems. And then always we'll have two rates that are related, and these rates are with respect to time. Okay? Now, I will say that people generally find this section pretty difficult. I think because these are like complicated word problems. But I am going to break down the procedure, and so if you follow these steps, hopefully you'll be able to make your way through these problems without too much difficulty. So, to get into the procedure, you will start by drawing a diagram, right? Sometimes, very rarely, it's not necessary to draw a diagram, but most of the time you should draw a diagram. And then next you should assign variables to your quantities. And these will be to any quantities that are changing. So this is actually an important part that are changing. You don't want to label anything that is not changing because then you'll have unnecessary variables in your problem and they can cause confusion. So it's better to only label things that are changing. And then once you've done that, once you've picked your variables, label these on the diagram. Okay. Next, you want to identify what is given in the problem and what you want to find. And this will be in terms of the variables that you've just assigned labels for. So okay, next you are going to find an equation that relates your two variables. And usually you do this using geometry. Sometimes you're given a formula, or you might use a formula that you know from earlier math classes. So usually use geometry for this part. Sometimes not. Okay, and then next, once you have your equation, you differentiate the whole equation with respect to time. Okay, and this will involve using the chain rule. So we've had some practice with this type of thing when we were doing implicit differentiation, and it will be really similar to that. Okay, and then finally, at the end, you substitute everything. So substitute in the known quantities, the ones that you wrote down in step 3. And sometimes you do have to solve for things that you you're not specifically given, but you can use your equation that relates your two variables to solve for it. So sometimes you need to solve for quantities that are not given. Okay, once you substitute in your known quantities, the last thing you need to do is solve for the unknown rate of change, the one that you're looking for. Okay, and so in each of the examples that I do in this section, I'm going to label each step. You don't need to do that, but it could help you when you're getting used to working through these problems. So I would say you can do it if you want to, and maybe I suggest you start out doing it, and then you can drop it as you get more comfortable with these problems. Okay, so here is our first example. It says that a balloon is being filled with air at a constant rate, given here, and how fast, it asks how fast is the radius increasing when the radius is 3 centimeters, okay? And so the idea here is that the volume, so the size of the balloon, therefore the volume, is increasing over time due to the air being pumped into it, right? And then that the volume and radius are related. So as the volume changes, the radius also changes because these two things are connected, they're related to each other. So we can figure out the rate of change of the radius from knowing the rate of change of the volume. And that's basically what this question is asking us to do. So we don't need to draw a diagram because this one's already given here. So that would be the step one. Right. Okay, in step two, it says to assign variables to any quantities that are changing. So the things that are changing are the volume, so we'll use V for that. Remember, volume is changing over time, so it's a function of time. And we'll generally always use T for time in these problems. So this will be the volume of the balloon, and then R of T we'll use for the radius of the balloon, right? Okay. Now in step 3, we want to identify what is given and what we want to find. So what is given, first of all, we're given that the balloon is being filled with air at a constant rate of 2 centimeters cubed per second. So if we want to write that down in terms of math, in terms of derivatives, we would say that the volume, so this is as the air flows in, it's changing the volume directly. So the volume is changing at a rate of 2 centimeters cubed per second, but we won't put the units on it in this case. So it's constant, so it's just equal to 2, and that is, yeah, that's the first piece that we're given. We're also told that the radius will be 3 centimeters. We're really told that this is the point in time that we care about, is when the radius is 3 centimeters, but we'll write it down as something that we're given. Okay, so we're also, so I should label this. Okay, so we're given that dv dt is equal to 2 and r is equal to 3, and we want to find the rate of change of the radius, so that is dr dt, right? Okay, now Next in our list of steps, we want to find an equation that relates your variables. Here we have a formula for the volume of a sphere. So see, we're assuming that it's a perfect sphere in this case. And we have a formula for the volume that involves the radius, right? So we just use that formula, right? This is an equation that relates our two variables. Oh, sorry, cubed. So I don't necessarily expect you to have this memorized. If you need something like this on a quiz or exam, I would give you the formula. Some things that I would expect you to have memorized, like say if we needed the area of a circle or a triangle or some more basic shapes like that, I would expect you to know those formulas. But I'll say more about that when you're actually going to be tested on this. Okay, so that is our formula, and the next step is to differentiate it with respect to time. So remember, both v and r are functions of time. They are both changing over time. So when we take the derivative, we'll get on the left-hand side just dv dt, the rate of change of v. On the right-hand side, we have a constant, so that's 4 pi over 3, that stays out front. And then on r cubed, we have to use a chain rule. So first we take the derivative of r cubed, so that's 3r squared, and then we multiply that by dr dt, right? So that's your derivative of your outside function multiplied by the derivative of the inside function. Right. Okay, so we are almost done. We just need to substitute in our known quantities and solve for dr dt. Now it's possible to do a little bit of simplification, so let's do that. And then go ahead and plug in the known quantities. So we have dv dt equals 2. So I'll finish this over here. So we get 2 equals 4 pi, and then we're also given that r is equal to 3, so times 3 squared times dr dt. So that means that dr dt is going to be equal to 2 over this whole thing. So we'll write it, 3 squared is 9 over 2, and then that would be simplified to 1 over 18 pi, right? Okay, so that is going to be our answer. If we want to know what the units are going to be, well, our radius is measured in centimeters and time was measured in seconds. We know that from the rate of change, the way that it's given. So we get centimeters per second. And that is our answer right there. Okay, and so we'll do another example in the next video.